Here's all my work for this parametric one, in case you just want to check your work real quick there, and then we'll talk about each piece individually. When you want to find position, you got to always take into account the initial position. So if we want to find the X position, notice that's why I underlined this at the beginning here, all right? It says at time t equals 2, our object is at that point. So which means our X initial position is at 1, our Y initial position is at 8. And so if they want to find the X coordinate at t equals 4, here's what we're going to do. At the X position at t equals 4, you're going to start with what they told you, all right? So you already know where you're at t equals 2. You're at that position of 1. And then what you're going to do, you're given the dx dt right here. That's how fast your x's are changing. We know when we integrate the dx dt, that's going to give you your x's, like your position of your x's there. And we don't quite know the dy dt. But when you integrate the dx dt, if you already know where you're at 2, at t equals 2, then you pick it up where you left off and you integrate it to where you want to go, which is the 4, right? So if they told us at t equals 3, our position, then I would have been x of 3, and then I would have started this at 3. So pick this up where you left off, where you're given, and then go to where you want to go. And this tells you how far your x changed in between 2 and 4, and this tells you where you started right there. So you do the initial position plus where you changed in that time interval, and then do the math 9 on that, and that gets you that decimal answer. For letter B, it tells us dy dt is equal to -7. Write an equation of the line tangent to the curve. Now, when you want to write an equation of the tangent line, you need the slope, you need the dy dx. And on the parametric ones, if you need a slope of the curve, the slope of the tangent line, if you need the dy dx, that's just your easy formula. The dy dx is dy dt over dx dt. And then the dy dt, they already told us, is -7. And then the dx dt, we have the dx dt equation. So we just want to take the 2 now and plug that in place for the t. That's what I did right there. And then that gave me the dy dx. So we have the slope, that's the dy dx, and we have a point. So if you want to write the equation of the tangent line, just do your point slope form, and then boom, you're done with the equation of the tangent line. You're allowed to leave it like that for full credit. When you see speed, okay, I gave you the notes for this in those extra video lectures there, the BC extra video lectures. The speed is just simply the square root of the dx dt squared plus the dy dt squared. So the speed at x equals 2, and that's to the x prime, that's the y prime. So the speed at t equals 2, that's going to be x prime of 2 squared plus y prime of 2 squared. The x prime of 2 squared, that's when we got to take the 2 and plug that into the dx dt. This is like your x prime equation there. So you plug the 2 in right there. And then the y prime of 2, if they gave me a dy dt equation, I would plug it in, but they didn't give us that. And so I didn't know what that was, but that's okay because they told us the dy dt at t equals 2 is equal to that -7 number. So that's just really just memorizing your formula from your notes there, and then you're good. All right, so just some calculator work with that. And then letter D is just a little bit of a roundabout process right there. But I think you'll like these parametric equations there. So it's mainly just start with this formula. So they tell us the line tangent to the curve has a slope of that. When they tell you the tangent line has a slope of that, they're giving us the dy dx. So here's my mindset there. I think you'll like this. When you want to find the acceleration vector at t equals 4. Now the acceleration vector is just that second derivative vector, okay? Now, you already know the first derivative. Okay, so what we want to do is take the derivative of that and plug in 4, but you're on the calculator part of the test. You don't necessarily have to take that derivative by yourself. You can just math 8 that thing. Watch a graphing calculator video if you need a refresher on that. But if you just math 8 that function at t equals 4, it's going to give you that 2.303 right away. So the problem is, so it's real quick and easy to get that x double prime of 4, but the challenge is to get the y double prime of 4 because I don't have a dy dt function. If I did, I can math 8 it, it'll take the derivative for me and plug in 4, and then I'll be done. But here's what I got to utilize. They gave me this dy dx, right? And so if they give me the dy dx, I just start with that basic stuff. Dy dx is dy dt over dx dt. They told me the dy dx is that 2t plus 1. I did not know the dy dt, but I did know the dx dt. So then look how easy this is. You could just multiply both sides by that denominator, and then boom, you just created for yourself that dy dt. Even though they didn't give us this, you just created that for yourself, and now you have the first derivative of the y's. And now what you want to do is take the second derivative and then plug in 4. So you don't have to take this derivative on your own. So this one I actually just plugged into the calculator. I got that ready for you. But if you hit the math 8 button and then I'm typing in this function, right? And just use x's for your variables all the time, where you have thetas or y's, just a dummy variable there. So then notice I type that in just like that, and then at the x equals 4. So it takes the derivative of that for me. And so that is the second derivative of the y's at x equals 4. And then that's how I was able to obtain that y coordinate. And then there's my acceleration vector right there. So a lot of these parametric ones are kind of similar like that, where you're just kind of utilizing those formulas, and it's very algebraic and systematic. So I think you'll like those. Spokes, like on a bike tire, spokes.